So Stripe needs no introduction. So they were founded in 2010. Most developers have come into contact with their payment infrastructure at some point, and today the company processes over $1 trillion in payment of volume annually, which is a wacky number to even think about. Their code base spans hundreds of millions of lines of code written primarily in Ruby, but today at Stripe, thousands of pull requests are merged every week containing 0 lines of human written code. And they're performed and created by Minions, fully autonomous, end-to-end coding agents that start in a Slack message and end in a pull request ready for human review. There's no human in the loop, no supervision, just the agent, the code base, and the task that it's working on. So my guest today is Alistair Gray, software engineer on Stripe's Leverage team, responsible for building internal products that help Stripe engineers do more. Alistair wrote both parts of the Minions blog post series, which you should go check out if you haven't already. And he's here to give us a deep dive on how they actually built it. So Alistair, welcome.
Hi, good to be here.
Amazing. So we spoke briefly just before this because we would like to do a quick demo of Stripe Minions, but it will take a little bit of time to run. So rather than staring at the agent logs, I think I was going to hand straight over to Alistair. We'll kick off the Minion job. We'll have a quick chat, and then we'll come back to it hopefully when it's had a bit of time to cook.
Just to set up the problem that we're going to have an agent work on, this is Trailhead. It is Stripe's central internal wiki for engineering docs. And I'm going to take this Jira ticket I have right here. The way it goes is roughly that we send some toasts in when we need to send the user notifications on our front end. And we used to use an external package for this, but it turns out that our design system, Sail, has a new toast component. So I would like to be able to replace all the usage of our React Toastify with this new component. So I'm going to show off how I would use a minion to go about that. So this here is Stripe's web page for minions. You can also kick them off from Slack, but for now, let's stay here. And I'm going to be working on this Jira ticket. So I could ask a deep search style agent what would need to be done for this ticket. And if I give it a link, we can see this is the kind of thing that you might do before you kick off a minion. You ask an agent to look at a ticket, see if it is feasible, what a solution to the ticket might look like. So this is just going to go off and read a whole bunch of code. It's going to think about what's necessary, and it's using SourceGraph's code intelligence tools to be able to follow links between files here. And while it's doing that, it will be formulating what would need to do to migrate to this new component. I'm just going to let the agent go. This will kick off a minion run that will allocate a dev box. It will start working. We'll come back to this once it has a solution ready.
So just to set the scene then, so whilst those minions are cooking off in the background, so Stripe is quite a unique sort of company, right? So at this point, 15 years old, so you have hundreds of millions of lines of code, and you will have a relatively unusual sort of Ruby stack. And I think you addressed this in one of the blog posts as well, sort of talking about how you have quite a lot of proprietary technology that maybe the models aren't trained on as much. Could you maybe talk us through what that environment sort of feels like to work in as an engineer and what that means for the challenges that you face when building something like Stripe Minions?
Yeah, it's really interesting because, lots of big companies have quirks about their setup, but we think that Stripe is a particularly unique environment. One thing is that we are a very large Ruby code base, but we don't use Rails. It is pretty uncommon nowadays to have Ruby code bases without Rails, but that's the original language Stripe was written in, and still the majority of our code ends up in Ruby without Rails. So out of the box, most agents and most coding tools have a little bit of difficulty with that. A native agent will try to use a lot of Rails idioms in Stripe code when it ends up being the case that we've built our own frameworks that encapsulate so much about what it means to run an API. It is all custom. There are many, many layers of custom everything. And just having such a large code base that is on a relatively uncommon stack means that out of the box, agents need a lot more information to be able to effectively work within the code base and use the abstractions that Stripe has. So it's definitely an adjustment period, and we have to steer them appropriately to allow them to work effectively there.
I think in a couple of the blog posts, you almost mentioned that you have to sort of prime the agents with sort of aspects of the context. I don't know if that was sort of related to what you just showed us here in terms of the source graph doing traversing through the code base. Is there anything that you had to set up to sort of specifically almost like bootstrap the agents so that they can sort of work better inside the code base?
Yeah, I mean, we end up using a lot of agent rules is the easy way to do things. We have translation layers that different agent rule formats can be shared between different types of coding agents at Stripe, and minions can read those as well. So if you have an IDE coding agent or something that lives on the CLI, then usually those will be able to deal with the same things that minions do, which is nice because it means that if we're dealing with a Ruby abstraction that's specific to Stripe, we can write that down once, and then all of our agents will be able to handle that abstraction well when they use it. Of course, it introduces a different problem around scaling for a huge code base, but we can get to that separately.
Amazing, of course. So one of the things that kind of stands out to me about in the blog post, and you think you touched on this a bit, right? So for Stripe, you had existing infrastructure. You had effectively these dev boxes. So I think that might not be entirely typical for developers working in different organizations. But then you were able to effectively sort of leverage this existing infrastructure that you had that developers were working in. How much of effectively Minion's success was then owed to that sort of pre-existing infrastructure investments that you had?
Yes, so you would absolutely call it a strategy credit, right? Stripe had great dev boxes, and because of great dev boxes, we were able to have a great agent experience. I think it goes pretty deep, honestly, in that almost all of the human-focused developer tooling that we build can also be used to make agents better. I guess it's just kind of a general truism that if you make infrastructure that humans can use, then you can probably get agents to use it too. So if you have great human-facing infrastructure, then you have great agent-facing infrastructure. And yes, that totally starts with dev boxes, right? Just like having a reproducible developer environment at all, really non-trivial in most places. And being able to spin one up as quickly or reliably as we are able to do has been just a huge tailwind to the success of Minions and agentic coding at Stripe overall. It's the kind of thing where a human would be able to parallelize so much more effectively with this abstraction, and that heightens how agents are able to parallelize just as well.
Yes, and I wanted to ask as well because I spoke recently also with Uber, and Uber also had sort of their own internal similar environments. They have DevPod, but when they sort of invested in background agents, they almost started off with it sort of separate. And then what they've then started to do is like blend the user experiences together. So they have, almost their foreground developer experience, and then there's background agents, and then sort of bring them together so that you can kind of swap between firing off a background agent or a minion in this context, but then also swapping back to being able to have like an editor or other ways to access that environment itself. How is that working out for a Stripe? Like how much time are people spending then in their editor versus these sort of background agents? And are you blending those two UXs together? Or are you seeing that people spending less time outside the IDE now?
I guess the beautiful thing about our background agents using the same surfaces as our developers do is that handoff is really seamless. Um, when a Minion run is done, it has a dev box, an environment with some code changes locally, and that is exactly the same thing that would happen if a developer was making that change themselves. So they can SSH into their dev box, they can point their IDE at it and get to working or get to testing manually against what's running on their dev box. We see a mix of how often that's necessary. A very large proportion of Minion runs are one shot it and merged. That's kind of the golden path, but we absolutely want to make it possible to iterate on them. And so using the same technology that we would use for a human making the change manually means that the handoff is pretty seamless. It's quite slick.
So you touched on one aspect there. So this is one sort of key part of the blog post. You talk about sort of unattended, like one shot kind of agents. And in part two, the second blog post that you put out, you also talk about this idea of blueprints, which for me is a very fascinating idea. So as someone as well that's been spending a lot of time trying to squeeze as much of the long running aspects of agents as I can, you do start to realize that you do need to blend the wonderful non-deterministic creative aspect of an agent, but also with the deterministic aspect. So you need to sort of somehow force it through gates or checks or certain steps that you wanted to take. and I could see that as well in some of the sort of blueprint design. So could you just run us through sort of what a blueprint is and what problems they're trying to solve for you?
Yeah. So the golden path with a minion is that we want it to be able to fire off a prompt and then not think about it until you have a branch and a PR that's ready to go. And in practice, getting a code change ready is a pretty non-trivial series of steps at Stripe and probably at a lot of other places, right? Like you've got to make sure your tests are passing, right? It is a pretty basic one. You've got to make sure that your linters are running, and Stripe has a lot of generated code processes that use the results of some code somewhere to populate something else. Every company of our scale has a lot of different things that happen when you make a code change, and it's just not worthwhile, if you can avoid it, to have the human think about these things at all, right? So when we create a blueprint, it's kind of an encapsulation of what we want a human to think about, and then all the other stuff that the agent is going to have happen anyways. And if it's not worth having a human think about it, which is the case for making the linter pass or whatever, then it's probably not worth it for the agent to really be thinking that much about it either. And if we can more reliably say, hey, the linter is failing, we have an auto fix, let's accept it. That sort of thing goes into a blueprint so that a human doesn't have to think about it, and an agent doesn't have to think about it, and the actual code change at the core is what the minion is focusing on. And the blueprint is all the stuff supporting it that can get it to a valid code change that our systems will accept.
Amazing. How does a blueprint almost look today? Because I know it's almost like a graph structure with these sort of nodes. Is that built on top of some existing framework? Because I know also you effectively forked Goose, right, as your harness. I don't know if that's still the case here, but is this something that you had to sort of build yourself to sort of create those blueprint graphs, or
This
is
is
that built on top of?
completely house built. I think I'm not sure, but I think LangGraph is probably a much more built out version of the same concept. But at the time that we were developing this, it was just very early, and I'm pretty sure that these agent orchestration frameworks didn't really exist. We kind of had to roll our own ourselves. So yes, that's one of the things that we implemented in our fork of Goose that ended up being, at the time, I guess it was unique, but now there's lots of different graph-based orchestration primitives for agents.
And I presume exactly from forking Goose itself, like you've gained then quite a lot of control over the harness itself. It sounds like you have quite a lot of custom tools that you've then built. And I think you also have like a custom sort of MCP registry and things like this as well. Toolshed, I think it was called. I guess that you get a lot of that benefit then from having that custom control over the harness itself.
Yeah, it's really interesting because there's many harnesses out there, but almost all of them are built for a human at the keyboard who's using it, which is extremely valid, right? Like that's how a lot of code changes get made. But it's not quite the use case we had in mind for minions, because we wanted them to be completely unattended. That means that like there's some features that we don't need, or features that like rely on having a human on the other end that we can't rely on. So we had to build our harness in a way that's kind of opinionated and different than how a lot of other harnesses work. So yes, having our own fork and being able to build in deep integrations into our own systems like Toolshed, or everything that a blueprint does, has been really helpful in getting us to a place where we know exactly what's going on.
Yes, gotcha. So for I think a lot of people then that will read sort of the headline of thousands of these Minion produced PRs will then obviously start to wonder about human review. So one of the great things about having these conversations is we can almost transport people into the future. Folks that maybe don't have access to something like Minions who might do in the future. You're living in that place where you have lots of these agent-based contributions. Is that an area that Stripe has considered investing in with the sort of solving some of the review challenges, or have you found some other way to get around this?
Yeah, I mean, it's a really interesting question. I'm not sure if the industry really knows how we feel about code review and how it's going to have to change with agents. I can certainly say that Stripe is not moving money without human review touching the code. But there's lots of room around the edges, right? The Minion that I just had kicking off is working on an internal only documentation site. Plausibly, it seems that that would be lower risk than a payments API. And it seems plausible that there is a future where we trust our agent review systems enough to say maybe there's a lower level of scrutiny here. One human plus one agent is enough to approve a PR that's low risk enough by these factors. But like I say, I'm not sure that the industry knows what to do yet, especially at companies that already have large, well-established products that have people on call. It seems like there are still risk factors that code review is designed to mitigate. So I don't imagine that we are going to see the end of code review anytime soon, but it will probably modulate in response to agents.
Yeah, absolutely. And even some of the most sophisticated companies that I've seen have also been struggling with this. I think what you mentioned with some of the risk profiles is something that I see lots of companies also experimenting with. Like, can we compartmentalize the code base? Can we apply risk rules to different parts of the code base? So therefore we can spend more time on areas of the code that might make, a more impactful critical path, things like this. And then spend less time on the, simpler or internal things or documentation or other PRs that are maybe not as significant. But then there's also the conserving of the sort of now limited resource, which is the human themselves, like where we're spending our human time. And I think that's one other sort of big challenge also with the review itself.
Yeah, absolutely. And I mean, Stripe already had the concept of code owners. So you need approval from a member of a specific team to change this particular portion of code. And I think that's a pretty widely adopted concept. So it ends up, if you can say that some code is low risk enough that it doesn't need specific code owners, and you just need any other engineer to stamp it, then we're already saying that there's differential levels of risk, that this particular code base needs one of these particular people to have eyes on it. So it doesn't seem crazy to me that we could extend that and say an even lower level of risk needs agent eyes only.
Yeah, exactly. So one theme that has also come up with it within the topics of sort of background agents is how it changes collaboration between different people within the company. So I'm not actually sure for minions, is it that you have one developer can have many minions? Is there any capacity, at least within minions right now, for, let's say, multiple different people on a team to be able to contribute to the same individual sort of minion session? Or would you then still have to do that maybe via an issue, maybe something in Jira like you showed earlier on? Or is that something that you have thought about?
Yeah, it's a really interesting question. We've built on primitives that assume that each branch has exactly one developer responsible for it. But maybe that's not a constraint that's true anymore, right? There's branches that have 0 developers that are really responsible for it, and maybe it's the case that we need to change how we build things so that um, on the code level, you can have multiple people contributing. I can say that there are already lots and lots of business collaboration tools, Slack or Jira or Google Docs or what have you. And if those are the right places for humans to collaborate with each other, then we should absolutely use them and use their outputs as the inputs to our code changes. On the level of actually connecting an IDE to a branch, it's not as clear to me that real-time collaboration or unlimited collaboration is going to cause the most clarity there, when it's really the conceptual level. I guess the thing about agents is that they make the code itself kind of an extension of the conceptual level. So if you have humans collabing on the conceptual level using conceptual tools, then the minion goes off and does the implementation. Then that seems to me more likely as the way collaboration is going to work, rather than necessarily having multiple people working on the same code at the same time.
Gotcha. And have you something that I've seen working with background agents in general? So you give a UI with the ability to sort of prompt within it, and that really like lowers the barrier to entry almost for other people to get involved with the engineering process itself. I'm not sure. Is that something that Stripe is seeing? Are you seeing sort of designers, PMs having access to minions or?
Yes, all kinds of AI dev tools at Stripe are being adopted by non-developers, and it's great because we have a culture that really prioritizes craft and beauty is what we call it, which is being very meticulous about your product quality, going through your product and coming up with 30 different things that could be a little bit better. And one of the great things about having minions or similar is that designers and PMs and folks who aren't necessarily editing the code themselves can get from a conceptual statement of something that could be a little bit better through a branch and a PR and get to something that they themselves can test and put up for review by an engineer who can verify that the code looks good without having to bother an engineer for a little bit of their attention, right? I guess the whole thing with minions, the way we think about it is that our employee attention is the most precious commodity we have nowadays. We want to take as much of the time that people spend like translating concepts into code. We just want to cut that down as much as possible. And that's what minions are built to do. But it has the great side effect that if we can go straight from a change that we want to make to the change made, then you don't necessarily need to know as much about the in-between.
Yes, it's amazing that you touch on that as well, because it's something that I have spoken and also seen a lot as well, right? So the prevailing narrative, especially about AI, you can generate lots of slop if you don't prompt the agent, don't give a lot of context, etc. You can end up with sort of inaccurate results. But also, I really like what you said there, where it's almost like where you can drive up the craft and quality from this as well, because the small things that maybe you chose not to do, now all of a sudden you can do. You can fire it off into a minion, put it into the background. I find this myself doing this way more than I previously did before, where even these small things then become, these little nitpicks you end up picking up and then driving quality from, which is maybe somehow a little bit against sometimes the prevailing narrative. People that feel that AI itself can reduce code quality almost.
Yes, I mean, it absolutely can if you are, less than disciplined about it. But yeah, there's definitely some great extent to which a typo in your front end. If a PM notices that, then previously they had to go bother an engineer to find the right string to change, and that just doesn't seem like a worthwhile use of time. So that's a quality issue that agents can fix.
Amazing. So coming back to this idea also of the long running agents. So there is a sort of a key theme inside of the blog post that talks about sort of the integration with CI and how the agent itself can run the CI loops, but then you cap that after a number of runs, and also you try to, as best you can, kind of like shift left with some of that testing so that that's actually ran inside of the minion itself. So how are you kind of thinking about improving sort of feedback loop? How are you thinking about improving sort of the minion's ability to have its own feedback loop and verify its own work?
Right. Yeah, it's an interesting question because there's a lot of different factors that are competing here, right? If you do a full CI loop, then the agent will have the most information about what our automated systems can detect is wrong. But also, CI loops cost a lot of money, right? And they cost a lot of time. We don't really want our agents to be looping against CI if they have to wait 10 minutes, 20 minutes to get an answer back anytime. So we want to be able to push that left and put it in front of the agent earlier. Once again, this is exactly the same as humans, right? Humans shouldn't be iterating against CI. Anytime a human is in a loop where the only meaningful way they can test a change is by running CI over it, then that's a really painful developer experience. So we don't want that at all, right? We want to be able to, and what we have right now is we have an executable that determines tests that heuristically or probabilistically we can say, it seems like your change might run afoul of these lints, these tests. Let's run them right here, right now. We can even run them in a pre-commit. And if there's a formatting change, then we can automatically commit the format change so that CI doesn't need to fail to tell us that the linter didn't like our change. There's a lot of things like that where it's like with a blueprint, right? You don't want a human or an agent to have to think about formatting. Your system should just do it for you. And our whole goal with shifting feedback left is that we don't want humans to spend dozens of minutes pushing things and then fixing them manually and then pushing them again. It's just not a good way to build things. So that's why we made a lot of the choices we did in Minions and trying to keep things local as much as possible.
Amazing. Speaking of verification loops, has the Minion finished?
Yeah, actually, let's take a look.
Amazing. Yeah, let's pull that one up.
All right. So we can see over here, we had a whole, a conversation. I'm not gonna go through the whole agent turn, but it looks like it did a whole bunch of things, and we ended up with a pull request. So if I clicked that button to create a pull request, and this is what we can, obviously I would want to test this myself, but it looks like this made a bunch of code changes that matched with what I asked the Minion to do, which was to replace this one package right here with our built-in component. So we started importing from this other file instead, which presumably has the component. And of course, I would test this before putting it up, but my agent looks like it came up with a branch as well as a full pull request description. So theoretically, once I test this, I can just create the pull request and we're good to go.
Amazing. What are you seeing in terms of split? So I guess we launched this from inside of the UI. What are you seeing in terms of like user split from Slack versus the UI, etc.? Like, are you thinking of other integrations?
Yeah, we have a ton of integrations. Honestly, the way we think about it is that the more the better. In Slack is very popular, and especially if you want to chat with other humans about what a change should look like, and that ends up often being the best place to do things in Slack. We push the collaboration to the collaboration tool side, and then the Minion takes care of the implementation, like we were discussing earlier. Alternatively, we have some Slack bots that do code search or searching over various other surfaces. So what a pattern we'll often see is people start a thread to discuss a change they want to make. They pull in a bunch of Slack bots to confirm their understanding of the present code or to look up other documents about what needs to be done. Maybe they pull in some other humans to verify that everything looks good. And then they'll just kick off a Minion and say, look at that whole thread and implement what I told you to do. And we find that that's a really powerful pattern because the place for collaboration ends up being where the collaboration happens. And you don't depend on the unattended agent to figure out what it needs to do. You figure out what it needs to do in collaboration with everyone else. And then the Minion takes care of the implementation. We also, of course, see a ton of usage from the web UI. Sometimes you just don't need a Slack thread to know what to do. And this has a lot of integrations into other places that Minions get used. So we have many different ways to kick off a Minion, and we love them all equally.
Amazing. So one question that often comes up with these agents is the security around them, really, and the ability. Obviously, if you're giving an agent sort of a long running task, that how do you sort of effectively govern this and provide guardrails? I think one control that you'd mentioned is the Minions are running themselves in some sort of testing or staging environment with sort of no sort of production data access. Is there additional checks and balances you've had to put in place to ensure sort of security for those Minions themselves and those runs, and make sure that they can have as much autonomy as possible without actually necessarily then compromising security at the same time?
Yeah. So it's an interesting confluence of things is that people's laptops are their most privileged thing, right? Something that is tied to your personal identity, such as your laptop, is generally going to be the most privileged place to run something. It also makes a bad substrate for background agents. If you want to have many background agents running on the same machine, they're going to step on each other's toes, right? Even if you have work trees and so on, there's going to be shared resources that all of your agents are trying to use at once, even literally on the level of, you only have one GPU, right? So having our agents running off in other boxes on the cloud is a really great way to make them more reliably effective. And it also gives us many of these security properties that you were talking about. Since our developer environments are not person scoped, they are cattle, not pets is the term we use, they end up not having this privileged access that something like a laptop would have. So there are credentials that dev boxes have, but there are credentials to do things as dev boxes. And our systems understand that This means that they don't get access to a lot of sensitive stuff. And we have reads on what is on a dev box because it's a reproducible environment. A laptop is a little bit more personal. People, well, of course, we have controls around such things, but in general, there's a lot more variation on a laptop, and it's harder to say what an agent running on a laptop can do. Whereas we can actually enumerate that for a dev box because we know what exactly goes into the image.
Yes, and actually, I mean, mentioning that as well in the isolation. So I think there is now actually a lot of awareness in the industry in general about sort of sandboxing. I think that is becoming almost like the foundation for sort of agent security for sure. This needs to be in some sort of sandbox, isolated environment, and then you can layer other controls on top. But for sure, it seems that everyone is aware that that is a really great sort of control. One thing that we didn't touch on necessarily, which I would like to come back to, I suppose, is the dev boxes that you have. Primitive wise, they're EC2 VMs, if I remember correctly. I just wanted to sort of ask, if lots of people are in this position where they don't have dev boxes like you do inside of Stripe. Would you do anything differently today if you were to be sort of building these out on a separate primitive? Lots of people now, I assume, are looking and thinking about where do we run these agents then, and what primitive is the right primitive? Is it micro VM? Is it Firecracker? Is it running inside of my CI, Kubernetes, EC2? Would there be anything that you would maybe do differently, or has that sort of infrastructure investment paid off for you?
It's absolutely paid off for us. I think if I were giving advice to someone trying to set this up for themselves, I would say that your first order of business is just to have a reproducible developer environment at all. Places where everything gets run off of laptops and everyone's laptop is a little bit different, and it takes you a week to install everything that you need to get started coding. That's going to be a problem if you want to have a large scale background agent workflow. So getting something reproducible that you can put on a container somewhere. Frankly, we use dev boxes. I'm not really familiar with all the panoply of options out there that exist for containerization.
Neither am I, and it's expanding at a daily rate.
Oh yeah, I'm sure there's a lot of people who are very interested in this. There's a lot of solutions that are coming online, but so I don't know if I can directly recommend one thing or the other. But being able to have a container that you can spin up is the most important thing in getting a good background agent. Yeah, it's really interesting. So among the things we're working on right now, we're making them better at front end changes. It is, obviously relatively easier to test backend changes automatically at all, but giving our agents eyes and allowing them to interact with sandboxed browsers to verify their changes is something we're working on right now. We're also thinking more broadly about what agentic testing looks like. Can you say, you know, in this directory, an agent can start up looking at this web page that's here, and they should be able to interact with it to do such and such a thing. Can we write that down in such a way that we can make changes here and have the agent verify its own changes, right? So when I showed that demo earlier, I said I would have to test this for myself. What if I didn't have to test this for myself, right? What if the agent could show me screenshots of what it looked like and give me a log of what steps it had taken to test a change? And then, that's a little bit less work for a human. There's also a lot of thinking we're doing about parallelism. It's great to have the minion actually doing the work for you, but there's still a lot of mental load involved with keeping track of all the agents. So how can we put our agents in one place and present them to the user in such a way that they can follow up easily, kick off new ones easily, and have a command center where they're doing less of poking into individual boxes. If they one shot, then they don't have to. So maybe that just means we need to make things more one shotable. But that's a few of the directions we're generally taking with minions. We think they're a great primitive to build on, but there's a lot farther we can go with them.
Amazing. They're both two really difficult challenges: UI verification, and then also
it's especially tricky because LLMs have kind of idiosyncratic vision, right? It's not necessarily going to be reliable to catch small things that are wrong. So we're doing a lot of thinking about it.
Amazing. So, Alistair, so I think that's probably about all we have time for. Is there anything else that I missed that's worth highlighting that you would share? Or
Right. I guess one interesting thing about how agentic coding works at Stripe is that we really believe in having a diversity of choices. So we have a good number of third-party tools for agentic coding that are available within Stripe, and minions are another piece of that puzzle. But we really believe in giving a lot of options, building primitives that different agents can use. So I talked about, for example, our rule sync or our central MCP server is also a way to have shared functionality. And one thing I guess the industry is learning is that there's a very you almost have a personal relationship to your agentic workflows, right? And different people want different things, and it's really great to be able to enable them all. I personally, maybe understandably, I'm a big Minions user. I really believe in unattended workflows, but other people, you know, have a shape of work where they want to watch the agent as it works. And so something that lives in a CLI or the IDE is going to be a better fit for them. So I think being able to enable as many different types of flows as possible is going to continue to be a big deal for the industry.
yes, definitely, and certainly for anyone that's worked on these internal platform tools, I'm sure that's going to help out with your adoption as well, rather than having just like one path or one tool that you have to use. Certainly, something that I've learned over many years is that developers like variety and also like the tools that they're comfortable with and don't necessarily want to always be confined to specific ways of working. So that makes a lot of sense as well.
Yeah, and I guess there's a general tailwind here, which is that when we build a product within Stripe for Stripe, we can be really opinionated. We can customize its flows for exactly how Stripe works, and that gets us some pretty nice benefits, as we've talked about with Minions.
Awesome. Alistair, thank you so much. I really appreciate you going deep into and showing everyone how minions actually work under the hood, especially since so many people are now thinking about this. Lots of people maxing out agents on their machines, like you mentioned, with work trees, etc., and also now thinking about sort of what's next. So I think it will be very helpful for them to have now seen this. I do want to give a shout out as well because you wrote two really nice different blog posts as well that are on the Stripe blog. So if people haven't seen those, so you definitely should check those out. So they're upon stripe.com. And the title of them is Stripe's One-Shot End-to-End Coding Agents, and there's part 1 and part 2. So yeah, that's it. Thanks everyone for watching and joining us for the session. I will now hand over to the rest of the team and take us into the next part of the program. So thank you very much.